All right, good afternoon. How you guys doing? Doing all right? Did you guys get a chance to try the Excel homework yet? Looked at it? Yes, no, maybe so. Not going to admit it, but you didn't. um, any questions before we launch into it? How do you feel about it? Feel like you could maybe do it without any help? Feel like those of you who looked at it kind of know where to start, maybe not, maybe, yeah. Okay. Bit of a mix. All right, so today we're gonna build one together. So hopefully you have your laptops. I see a lot of you that do. And even if you didn't, you could kind of sketch it out on a piece of paper and think to yourself, well, what would this do? You know, make kind of a grid, say, okay, well, this is gonna call to that piece and calculate it, right? You can imagine what Excel does, so hopefully that you could still find some benefit here regardless. So we're going to go through the prompt I have here, and then I also spent a bit of time this morning and realized the issue that I was having with MATLAB. We were actually very, very close to the solution last time we were trying to use MATLAB Solver, and the silly issue was that I was saying, well, give me negative log of h so that I can get a pH. And it was giving me a number that looked like it was kind of close, but not right. It was giving me the natural log instead of log base 10. So once I fixed that, everything was fine. So we'll go back and take a look at that. I'll show you after we do Excel what that looks like. And I didn't do it for this problem, but we probably could. And if we have extra time, maybe we will. Okay, so during today, please stop me anytime. And once I launch into Excel, I'll probably sit down and just be here typing away at my computer kind of alongside you there. And there's a lot of ways we could develop this, you know, a lot of ways we could format our Excel sheet. So kind of pick your own poison. We'll just walk through what's making sense to me. And hopefully you guys can ask questions and kind of piece it together also. So I'm giving us this prompt. To set up an Excel spreadsheet to use Solver to find the root value of H plus concentration. Of course, we're going to target the pH because the log scale, that's going to make it a lot easier. If we change the pH instead of H plus, instead of going from 10 to the minus 14 all the way up to 1 moles per liter, we're going to go to 1 to 14 or 0 to 14. So 14 numbers instead of that huge expansive range, 14 orders of magnitude. There's just a lot of numbers to guess in between if we were guessing at the H plus. So we're going to do that, and we're going to use that spreadsheet to find the pH and the speciation, meaning so we're going to have the Excel sheet give us pH, and we're going to have it give us alpha 0 equals and alpha 1 equals. That would also mean we could find for this solution of sodium acetate, we could go ahead and have it tell us, okay, what's the AC minus concentration and the acetic acid concentration. Okay, so those are the targets. That's what we're going to be after. And so where do we start? I think the best way to start any problem or task in Excel is to kind of pretend like we're not using Excel yet. In what I mean by that is we have this problem. What would it look like if we tried to solve it on our own, right? That way we'll at least sketch up a few equations, write down some knowns and unknowns on some scrap paper or the slide or whatever, and then say, okay, now I'm going to put all this into Excel. So that's, I think, probably a good place to start. And by the way, I'll come back to this and capture this as a screen grab to put in our Excel document so we kind of have the prompt to look at. But we're doing this, I don't think I finished reading the prompt here. We're going to use the spreadsheet to find the pH and speciation at a standard temperature pressure for a solution with 10 to the minus 4 moles per liter of sodium acetate. Okay, so that'll be the target. I realize I need to also give us the pKa for that, or the Ka value. I'll look that up in a bit. as we get going, but we need that. I think it's 10 to the minus 5-ish or something. Okay, so what do we know? Well, we know that a solution of sodium acetate has certain molecules in it, right? We're going to have water, obviously. So that means we're going to have OH minus, H plus, and NaAC, sodium acetate, is going to be just like any of our generic acids, NaA, that we've talked about. So we should have some sodium, some acetate, AC minus is how we'll abbreviate that, and we'll have HAC, so the acidic form of this generic acid. Okay? All that should be pretty clear so far. We've done this kind of stuff. And now we need the equilibrium equations, or mass action equations, we might call them. This is going to be for water. Its dissociation, and we know the Kw there. It's 10 to the minus 14. And then our acetic acid, HAC, in equilibrium with the acetate, AC minus, and H plus. And like I said, I need to look that up. I was basically taking this from an example, so I think I just forgot to grab that from the example. All right, so then the mass balance equations we'll need for this as well. We were given that the total acid concentration, I think, was 10 to the minus 4 moles per liter. Yep. And for every time we add some sodium acetate, this is going to enter the water as sodium ions and acetate ions. Of course, then the acetate will be in equilibrium, as we understand. So we'll get HAC, and it's not all in AC minus form, but Na plus doesn't do anything. So the same amount of total acid that we have is the same amount of sodium that we have. So we have no other sources of sodium in this scenario. So that means we could also say this is equal to Na plus. Okay. So we have a few things there. Anything else we've got? We could, of course, also write that the total acid will be the acetate plus HAC. We could also write that, if we really felt like it, in the form of the alpha fractions. Let's see, do we need to do that? Yeah, we could do alpha 0 times A total plus alpha 1 times A total, right? We don't normally write it that way, but I'm just, in case we care, just to remind us that the alpha fractions, what they're doing, is just showing us the proportion that is one or the other. Okay, and we might come back and elaborate on the alpha fractions as a way to rearrange some pieces or get pieces in the form from the equilibrium equation that we will have here. We could get, let's say, one of the, let's say, acetate in the form of, as a function of pH and the alpha fraction, or the pH and the equilibrium constant. So we will probably come back to do a little bit of that as needed. Okay, electroneutrality then would be the last step. And now that we have each piece in here, we can just take all the charged species and take a look at that. Say we've got all the cations on the left. Start with our Na plus our H plus. And that will balance with all of the anions, right? So we'll have OH minus and AC minus. So a relatively simple system. We've been looking at these generic acids for a while now. We've done similar problems. That's what our electroneutrality equation should be. One thing we can do is rearrange this and set it to 0 just by subtracting the right-hand side. So left-hand side minus right-hand side equals 0. And that's probably what we are going to do in order to put all this together to find a function of pH, or of H plus rather. So if you recall, that's to solve problems like this, that was the target, is to just from here use algebra. So we've set up some stuff with chemistry, but it's really all just algebra that we're going to use. Okay? So now we have several equations based on the chemical principles, and we're going to algebra it until we can find the pH. Okay? Now that's where we're going to realize, oh yeah, let's use the solver. So from here, we can say, here's the basis of the electroneutrality. Let's go ahead and rearrange it in terms of left-hand side minus right-hand side equals 0. So that'll be H plus, which is nice. H plus is our target. So if we're doing algebra, that's X. X plus something, plus whatever, minus whatever equals 0, right? And then we're going to solve for X. So H plus plus Na plus minus A minus minus OH minus. Okay, and all that equals 0. So hopefully that's very clear, obvious. The question is now, how do we algebra this in order to get it all in terms of X instead of these other unknowns, right? And here's where we're using the system of equations to get it there. So if we can get everything in terms of H plus, then we get a nice equation, and then we're going to go and realize, that's not very convenient to solve, let's use Excel. So we actually have to do a lot before Excel in some way. And so if I just jump straight into Excel, we'd kind of forget that we learned this stuff earlier, I think. And these are the pieces that we needed to go through to get to that point where we're punching it into the solver. Okay, so first up, OH minus. How can we get that into H plus, some function of H plus? Yes. Everybody hear that? So we're going to use the equilibrium constant for Kw, right? We know Kw equals OH minus times H plus. This is coming from the equilibrium equation. This would also be over the concentration of water, but we always say that because that's liquid water, this is basically going to 1. So we kind of neglect it in that regard. So that means we can, instead of put OH minus, we can write this as H plus over Kw. Excuse me, backwards. Kw over H, or H plus, as was said. So you divide both sides by OH minus, by H plus to get this guy in the form of H plus. All right, so I'm just going to build the equation in this manner. So that was the first step. Bless you. And we'll go ahead and say that's for that part. Now A minus, what do we do there? What equations do we have that have A minus in it? So we have HAC minus, so you're saying HAC minus, sorry, say that again, what did you say?
HAC minus H plus would be equal to the concentration of H.
No, I think you're rearranging from, I'm not sure where you're rearranging from. From the equilibrium. Right, this we cannot arrange in that way because this is not, that doesn't imply it is, that's going both ways. We can't just say that's equal to, right? Yeah.
We can use alpha 1 equals A
Yes, and where is that coming from? Which is, I think, where you were coming from here. What does that equation come from? On this page. Bless you. It comes exactly from what he was mentioning, is the equilibrium equation, right? So that we can get from the equilibrium equation an alpha arrangement. Okay, so let me elaborate on that just a little bit here. From the equilibrium equation, which says Ka is equal to AC minus times H plus over HAC, we can manipulate that and get it in terms of an alpha fraction. Okay, we can also manipulate this into a function of Ka and H plus. So we will see these two are kind of lead us into what you were mentioning there with the alpha fraction. So I'll rearrange this just a bit to show us how to solve this in terms of AC minus, first of all. So if we just solve in terms of AC minus, that way we could maybe substitute something. This becomes, we multiply both sides by HAC, so this will be Ka times HAC divided by H plus. Okay. So we could put that straight into the equation that we're working on, but we still have an unknown in the HAC. So what might be a little better is to go ahead and get it towards the alpha fraction, because once we know the pH, we know the alpha fraction, or we should be able to. So that, in a sense, the alpha fraction is also a function of pH when we set it all up. So probably what I ought to do is write out with you what do the alpha fractions equal as a function of pH. Then we can start using those and say anytime we have an alpha fraction, we know that's going to be there. So just taking this for a moment though, how can we rewrite HAC in terms of an alpha fraction? That's a question to you.
Isn't alpha naught times A total?
Yes. So alpha fraction literally just means the proportion is this form of the total, right? So if we want to know HAC, that's we would need to take the total times the proportion that is HAC. So remember, alpha 0 corresponds to the protonated. It has lost exactly 0 protons. And alpha 1 is corresponding to the type that has lost 1 proton, which would be the AC minus here. Right? So that means we could rewrite this. I'm just going to save this here. AC minus we could write as Ka times H plus divided by, excuse me, I messed that up. Ka divided by H plus. On the top, we also have multiplied by this alpha 0 times A total. We're given A total, so we know that. And then as long as we are looking for something as a function of pH, well, the alpha 0 we can put in terms of pH. I'll come back to that and make sure we're on the same page on deriving that. It's another thing perhaps I could have put on this slide to begin with. But that gives us something to work with. So in this portion here, we can take that substitution. And I'm going to flip back and forth so I get it all in the same spot. We said that's the equilibrium constant times alpha 0 times A total divided by H plus. So I'm going to put that here. Okay. Now, what are we going to do with the sodium concentration? Already given, exactly. So we can just put A total or 10 to the minus fourth, whatever we want to do there, that's fine. And of course, H plus is fine, right? Okay, so we're almost there. We just need to figure out what to do with this alpha 0, right? So let's remind ourselves, what exactly is alpha 0? This is technically the proportion of acid that is in that is in the protonated form, the form that has lost 0 protons, right? So that should be HAC divided by the total, and I'm going to write this as simply HAC plus AC minus. Now that currently feels like it's just a bunch of unknowns, right? But I'm going to do our little trick we've looked at a few times. Simplify this down a bit, divide the top and the bottom by the numerator, and say this is going to be the same thing as writing 1 over 1 plus AC minus divided by HAC. And here's where we can get, since we have that ratio between HAC and AC minus, that's where we can insert our equilibrium constant information to transform it into H plus and the equilibrium constant. Because anytime we have those two compared to each other, we also have an equilibrium between the two, right? And we can make that comparison. So I'm going to pause here and say, just put this over here. We know that our Ka is H plus times AC minus over HAC. And that is almost already in the form that we need to substitute, right? So Ka divided by H plus is in that form of AC minus over HAC. So that means we can take this guy and put it right in here. And I made a bit of a mistake not giving myself enough room right in here. So I might rewrite that. So then we can get the alpha 0 fraction then in terms of this Ka value and the H plus value. So let me rearrange just a bit. So alpha 0 would be equal to 1 over 1 plus Ka over H plus. Coming from here. Okay, so then when we put that all back into the equation, then we can see what's going on. I'm going to shift this little guy down a little bit real quick. I should have given us a little more room there. So I'm just going to rewrite this part. Sorry. Okay. So finally, we get an equation that looks like this. H plus 10 to the minus 4 minus, and here's where that alpha 0 is going to come into play, right? So we're going to multiply Ka times At to the numerator and the H plus to the denominator. So I'm just going to go through and do that. On the numerator for this guy, it's 1, so that's just going to leave us with a 1 at the top. So that'll leave us with, and we're substituting for that guy, right? So we're going to be Ka times At, and on the denominator, we're multiplying the H plus across these guys, so it'll be H plus Ka. So I've done that correctly, because it'll cancel that one. All that minus Kw over H plus. All that equal to 0. Okay, does this make sense enough? It's a fair bit of algebra to combine the pieces, and it makes sense that I'd kind of have to remind us, okay, we can do this ratio, we can do that substitution, but it's all just algebra to get there once we set up the chemistry. Now we're looking at that and saying to ourselves, that's gross algebra. I don't want to solve for H, right? So now's the time where we say, okay, let's go to Excel. All right, a couple things as we do so, and I'll copy some things over and I'll also get us that Ka value that we need. I always like to set up an Excel sheet with a little bit of basic information. What's the date? What am I working on? What's the problem? You know, maybe I'm preparing solutions for an exam or something. Put some info for my later use, right? Or if you're turning this in, maybe put your name on it in the Excel document so I don't have to like go back and look at the file name. Oh, homework 1 Excel, just like everybody else's homework 1 Excel document was named .xls, right? So maybe put your name on it, put the date in it, you know, that type of thing in Excel itself. That would be good practice, just kind of a little bit of professionalism with your homework, just like you'd put your name on the homework, right? Add some context equations for your reference. So all this stuff that I just did, let's put at least some of that into Excel so that we can be thinking about, okay, here's the equation I'm trying to work with. This is what it should look like. And where are we going with this? Then we set up cells, some cells for just stuff we know, and some cells that we don't know but are going to be calculated. And as we do that, we try to design so that we could change things in the future, right? So rather than building in this Kw as 10 to the minus 14th and just writing it into the equation when we get to this step, we could just write that in as 10 to the minus 14th. But I recommend we put a cell there instead in case, I don't know, maybe we change the temperature and suddenly we want to use something slightly different. That lets us do that so we can sort of think ahead a little bit. Oops. Okay, so with that, I'm gonna get going with that. I'll write up a few tips here as we go, and you can hopefully work with me as we do this. And how are you feeling so far? Is it now that we've done that part, you feel like you could do the problem? So if I give you the alpha fraction equations on an exam, do you think that simplifies things for you so you don't have to go through and derive that? Okay, I think you guys know or could memorize how to derive those. I think you guys are perfectly capable of that, but it's a lot of extra steps along the way, I think, when maybe you're not thinking of it. Okay, so let's set up an Excel sheet, right? So I think I've posted this and I will post this. Previously, we looked at this example here or a very similar example. This is from not the primary book, but the other book. just like this example is also. So let's write up a few things. First thing I'm going to do is I'm just going to go ahead and take a screen grab. By the way, I like to use, this is going to be interesting. I like to use the screen clipping tool in Windows. That is Windows Shift S will allow you to grab a little screen capture like that. So I'll shrink this down to size a bit just to kind of deal with what we're working on. So this is the equation that we derived, and we're going to have to put that into some sort of a, Excel formula. And probably another thing I should do is go ahead and get the prompt that we were given. I'm going to do the same thing. Okay, so at the end of the day, we want to solve for pH. We want to solve for alpha 0 and alpha 1. We could also then solve for HAC, oops, and AC minus. And I'm probably going to put spaces for these later. I'm just kind of writing down what I want to find eventually. Okay, so then we have some knowns. I'm going to go ahead and write a few down. We know KW equals, and of course, anytime I'm putting a number in, I will typically just go ahead and write equals 10 raised to the minus 14, for example. And then I'll hit enter. Could probably also hit tab, and that would go over 1. So 10 to the minus 14, that goes ahead and puts that value in there. We will or should also know Ka. I forgot to give it to us in the prompt, but I will look that up in a minute. So we're going to come back to that one, but we'll have it. We know the total acid concentration, right? That was given as 10 to the minus 14, or excuse me, 4 moles per liter. If you notice, I always put the units for it separately. By the way, you can double click the little column thing here, and it'll auto size it to whatever the normal size or the max size of that column is. So I'm always going to put the units separate, but I do try to track them. So another one of those little kind of professionalism type things. If we have units, go ahead and put them there. All right, and I'm thinking to myself, what else do we know? We had several equations here. We could rewrite some of these. And how about some unknowns? And here's where we probably ought to start writing up pieces that we know that we're going to need to either solve for or compute along the way. So stuff like alpha 0. We can put it in terms of the pH, right? And alpha 1. In fact, maybe I should go ahead and start with the master variable H plus itself. right? That will be equal to some number of moles per liter, and therefore the pH will be equal to 10 to the minus, negative log of whatever pH is, right? Right now it's has no clue, but if I put 0.1 for the pH, for the H plus, then pH is 1, right? So I'll just leave this as 0.01 for the moment. We're going to change this. This is going to be the target, or that's going to be something we're changing later, or the pHs, really. Yeah.
So, okay, so are you going to want us to be changing the H plus manually or the pH manually?
Okay.
Or does it matter because they're kind of...
It's a very good question, and the prompt itself tells you to find the pH, well, really find the root of H plus by targeting the pH. So I'm writing it up here as a placeholder. We're going to tell Excel to change pH. But we need a value of H plus, and maybe I just did this backwards. I probably did this backwards. We need Excel to be able to change something that affects H plus. So your question is exactly on point because I did do this backwards. Right here I was like, okay, arbitrarily some number, but the pH is the one we're guessing at. So I should, instead of calculate pH based on H plus, I should calculate H plus based on the pH that we're guessing.
I'm just wondering, because like when we do the graphs in class, we'll do the list of pHs all the way through 14, and so we kind of input those manually. Are we doing the same thing here?
What we did in class that time, we don't have to do here. It was to show you how the process was happening. That was kind of the manual attempt at it.
Okay.
We're going to skip some of the manual attempt at it, and instead of listing all that, we're just going to go straight to the solver.
Okay.
Is that all right for everybody? We could do that, and you're right to be thinking about that. Okay, so I'm just going to reverse these two. I realize that was maybe not the best way to do this. So in case you're interested, we could cut and paste this entire row. Just going to cut it and paste it. Control V to paste. And that just gets rid of it entirely, swaps it around. I'm going to delete that space here. And the reason I do that is just because I want pH above it, and that's just seemed like the simplest way for me to do it. I'm just going to set that as arbitrarily 2 and then tell this cell, H plus, to calculate based on 10 to the negative pH. 10 to the minus 2. There we go. So the only thing I did there was I just reversed it because I realized I was doing the process backwards. Okay, so we've got a few pieces now. We still have a lot to solve for, but we've got a few knowns written. I'll look this up in a moment. In fact, I'm going to go ahead and give you a couple minutes to think about where to go next and how to start setting this up to the point where we could set this equation up, set it to 0, such that we can tell Excel to use solve. Okay? So we have almost everything. I'm going to go ahead and look up this value for us. And I'm asking you to try to take the next step and see what you need in terms of pieces to put into place. Okay? Ka value is 1.74 times 10 to the minus fifth. Okay, I've got one little Excel tip to show you. We can use apostrophe to prevent Excel from doing like a equals calculation. So if we ever wanted to show ourselves what we're going to write in terms of an equation, we can put the little apostrophe and then equals, and I could say x plus a3 as if that's like some cell, and it's just going to write it out as if I was just writing text. So the apostrophe tells Excel that, hey, I just want to write some text here. So one thing I'm thinking to myself is, maybe I could go ahead and set up my equation, or maybe I ought to go ahead and write out these pieces here. And I forgot I don't have a, there we go. I don't have the normal eraser when I'm writing in Excel. So probably one thing I could do is just go ahead and write out a few of the equations that I'm planning to use. So going back to here for just a moment, one little tip, use the apostrophe to tell Excel okay. So that's one thing we can do, and what I want to do for that is remind ourselves, okay, we have these two equations, right? The alpha 0 and alpha 1. We derived this a moment ago in terms of pH. This was 1 over 1 plus, I think it was Ka over H plus in this case. Ka over H plus. And by the way, if we do the same exact derivation, but we started with it flipped, with AC minus the portion, so for alpha 1, we would end up with the same equation, except it's 1 over 1 plus AC minus over Ka. That means these are just flipped here. So coming back down to here, we can say that alpha 1 is 1 over 1 plus H plus over Ka. Okay, so that's the deal with the alpha fractions. They're always going to be rather related to one another. And when we go up to diprotic and triprotic systems, it's very similar as well. It gets a little more complicated, but it's the same basis. Yeah.
Would it be acceptable if we just subtracted the opposite alpha value by 1?
You could totally do that also, right? So alpha 1 is equal to alpha 0, 1 minus alpha 0, right? So that would be another completely fine way to compute it or whatever. So what I'm going to do here for this particular spot, all of that was an elaborate way to show you what I want to do here is to say this is going to be, the equation that I want to write in here is going to be 1 over 1 plus the Ka over H plus. And of course, that's not solving anything, but I'm just reminding myself I should set that up here. And so here I will go ahead and put in the pieces that would solve for that. Okay? And so I'm going to say this will be 1 over 1 plus, and then I'm going to grab Ka, which was right here, and divide that by the H plus value right here. Okay. I'm putting in this equation, the alpha 0 equation. I'm just putting it in this spot in Excel using the fields in Excel that I've set up. Right? So somewhere I put H plus and somewhere I put Ka. And so as I write it, I say equals 1 over parentheses 1 plus another parentheses Ka divided by H plus end parentheses. Does that make sense, kind of the process I'm doing here? I'm just setting up the relationships to connect each other. And I like the simplification that Mason mentioned. We could say alpha 1 is simply alpha 1 is going to be equal to 1 minus alpha 0. In a diprotic system, that's always true, so why not? We can say this guy is then equal to 1 minus this other fraction. Of course, we could also write the whole thing up. So either way we do that, that should be the same.
No, but this is for like some arbitrary value of H plus.
Yeah. Right now it's as if we're guessing, right? So earlier we were asked like, where are we setting this up to manually guess? Well, we could simply change this and watch everything change so far, right? So we could guess this highlighted spot. We're going to tell Excel to do that in a minute. Okay. Now, we can also then solve for the AC minus and the HAC. And by the way, we still have not put in the big function we derived, right? The left-hand side minus the right-hand side equation. So we need to do that soon. We need to get that equation put in here. And that's what we're trying to find as close to 0 as possible. That's kind of what we did manually that other time. So give this a moment to see if you can go ahead and put in some equation that'll find you AC minus and HAC, given what we have so far. And give a crack at this left-hand side minus right-hand side equation. I'm going to copy and paste this guy over here too. So if I derived this equation here correctly, I'm hoping I did, then, or we did, I guess, you were watching, then I think you should be able to finish this homework assignment from here, or this particular assignment, because we're very close. So see if you can get there. I'm going to give you 5 minutes. Okay? You're also welcome to talk to each other, ask me, whatever. how's it feeling? You get an answer, get almost there.
Is the answer supposed to be 0?
I don't know, I might have done the math wrong. Could be. Yeah.
When I changed it to 5, it went to like negative 5.35.
Changed what to 5?
The pH, because originally I had it to 300.
Okay, and you're saying when you changed this from 2 to 5, what changed?
The left-hand side minus the right-hand side.
Okay.
Changed from 1 to the negative, 1 e to the negative
So
2.
did you use solver yet?
Use GoalSeek. Did I not use that?
GoalSeek might be the same thing as solver. Might be a different way to get there. I'm not as familiar with it.
Because it's like returning negative value.
Okay, so here's the deal. The left-hand side minus the right-hand side is we're supposed to be able to find that where that equals 0. That corresponds to the pH. Where it's closest to 0 is the pH that the system would be under these conditions. Okay? If you recall, we made a graph last time we were talking about this thing where the left-hand side minus the right-hand side, that function would go through 0 eventually. And this is, we would say then, when it crosses 0, that's the right point. So we're going to tell Excel to try to get us to that right point. So what I'm going to do here is insert this equation and see if this is going to give us what we are hoping for. So, and I'll then show you the solver part in case you didn't quite get that piece and the aim of this. Because if you're guessing pHs, yeah, that's going to be a negative or a positive number depending on which way we're missing. So we're going to put in equals the pH, excuse me, the H plus right here, plus the total concentration, the sodium, that's 10 to the minus 4 there, minus, and here we have a category that maybe I could have done this a lot simpler. I'll come back to that in a minute. You know, I went through all this derivation to do it the more complicated manner, maybe. Maybe we could have just let Excel do all the details of the algebra if we set it up right. But since we did it, I'm going to go ahead and use it. So we're going to do Ka times At, Ka times At divided by H plus plus Ka so we had H plus 10 to the minus 4 minus all of that minus the OH minus, which is Kw over H plus. Okay. So now we have that number, and in order to force Excel to be even a little more precise, so this is the error. This is the piece that we're trying to get close to 0. And to make it artificially further from 0, I'm multiplying it by 1 million. Just to, when we get close to 0, it'll be more obvious. So here's me multiplying it by 1 million, and we'll go from there. So hopefully Excel will be able to change pH until this value gets pretty close to 0.
Why are you multiplying by 1 million?
I'm multiplying by 1 million because Excel might think that 0.1 is pretty close to 0. But in our system, there's a lot of values that are actually that close to 0. Yeah, we actually need to be like 0.0001 to call that close to 0. So that's just a sensitivity. I could multiply it by more. We could do 1 billion. And maybe that improves our accuracy a little bit. That's just to make sure that Excel's going to do really, truly close to 0. Okay. Now, one thing you'll notice here is I could have set this up, probably skipped us some algebra. So sorry for the painful lesson there. If I had simply said, as part of these unknowns, I probably could have gone in and said, well, we have OH minus, And we could set that equal to, and do this part first, the kW over H plus. So we could have done the OH minus concentration calculation there, and then skipped the derivation that I did because we just needed to, we already just did it there. So we could have used Excel to do a little more of the algebra for us. I'm sorry I made you suffer through all that stuff that you should know. So hopefully it was helpful. Okay, so let's try it. We've got this left-hand side minus right-hand side. I'm actually gonna use this as my target and say, all right, Excel, let's go to solver. So data, solver. There's probably another,
It's in the what if analysis is what I use. But
oops,
no,
sorry. Yeah, so that what if analysis or the goal seek analysis probably does the same thing. I'm just not super familiar with it. So feel free to take a look there. Okay, so it gave me some warning about setting the objective. I'm gonna set the objective here as this is the target that I want to set to a value of. Sometimes you could just say max or minimum. Minimum would probably also work, but I don't want it to go negative. So if I do minimum but set it, you know, as a positive greater than or equal to 0, maybe that works, but value of 0 I think is a better idea. And the way I'm going to do it is by changing the pH value. Okay, so the pH value is the thing that can change. Maybe I should constrain it to be between 0 and 14, and we can do that, but I'm going to try without in hopes that we don't have to worry about that.
Do we need the dollar sign when we're doing this?
It'll probably add it automatically. You do not need it in this particular case. It should calculate just fine because we're not moving it around at all. But when I just clicked the thing, it just automatically put it there. Okay. Everything else I think should probably be okay, and I'm just going to hit solve and see what happens. Okay, the solution popped up over here. It's just asking me, hey, do you want to keep the results or not? And I'm just going to click OK, whatever, get out of my face, and see what happens. So this got to a value that it's point something, but it's 5 digits away from 0.1 or 1.0, right? So it's something times 10 to the minus fifth. That's a pretty small number. And it gave us a pH value of 7.4. Okay. I see some confusion. What's going on?
Like I got a different number for the left and right hand side, but I got the right pH.
Cool. The value here, is it like a slightly different, like same order of magnitude?
No, completely different order of magnitude. But I have the same pH. Doesn't make any sense.
Sounds like to make it 8 on there.
What's the blood test?
0.5.
0.5, interesting.
Same pH though. Works, it works.
You know, on some level, if it works, right?
Oh wait, me too. Yeah, I got to a minus 16.
Okay, so what did I do wrong? Or did we all do the same exact thing right, and it's just... Well, Excel does make different guesses, but I'm a little surprised that they're that far off as the left-hand side.
To solve it.
Yeah, I mean, each time we do this, so if you watch, this is what I'm going to do real quick is I'm going to copy this so that we can watch what happens when I do it a second time. I'm going to go back to solver. Well, first I'm going to make a new guess. That's might be part of it is whatever the value was starting at might be our starting guess. So I'm going to put this to 11, and then we see it's pretty far away from 0. Go to solver, going to do the same thing again. Click OK on that. And now we have left-hand side minus right-hand side is a very different number than what I had earlier, right? But the pH is still the same.
Is it just that it's arbitrarily close enough to 0?
it's guessing. Yeah, so it's making guesses until it's close enough, and then it says, okay, we're good.
Okay, I'm getting a wind of this solver not finding the solution. Like, okay.
Yeah, usually you just click OK and see if it works. And the other thing we could do if it's really not working is you could probably put in a constraint to say this value, the pH value, has to be less than or equal to 14. And we can also put in this value has to be greater than or equal to 0. So now we have two constraints to make it fit within the pH range, and try again. And it gives me something there and solves it. So these numbers will change a bit, right? But the point is when you run the solver, it should get you the right pH, 7.41. And we can double check, and I'll show you what this solution in this book, oops. They set it up this way, and it looks like we did our math correctly. So they skipped some of the algebra, and we can take a look how, in case you want to skip algebra in the future. Who doesn't, right? So they just said, okay, our electroneutrality is here. Sorry, this is weird. Get out, stop. Okay, they've got their electroneutrality equation. They say our A minus equation is here, A1 times A total. OH minus is here. And then instead of doing all the algebra up front, they just, whenever needed, put in the number, like put in the cell for it to solve it. So they put in each of these components there. I think I actually have this in the, I did this before with a similar, the same problem, and set it up the way they did. So you'll have this second rendition of the problem if you want to look at it with some of the derivation skipped in the second page here. Yeah.
So for a moment, would the number that our left-hand side minus right-hand side equal matter? Because we're all getting different numbers, but the pH is good.
It's the pH that we're looking for.
Okay.
Right. So yeah, the left-hand side minus right-hand side, what matters about that is that it's getting close to 0 in order for us to be confident that we arrived at the right pH. Does that make sense, everybody? Okay. So this previous example here that I have in the same Excel sheet skips some of the derivation. I guess maybe it's a little more direct, but ultimately you're still doing the left-hand side minus the right-hand side. Okay, it's just a difference of where we did the algebra. Did we let Excel do the algebra for us, or did we manually do it and then bring it over? Okay. All right. Does that make sense? Any issues or questions? Was this helpful?
Oh, yeah.
Great. I'm up here not having a clue if this is helpful because I'm like, we kind of did this once already. I did it more ahead of time myself, and so I feel like I'm just kind of doing it over again. Good. I'm very glad to hear that. Okay. I wanted to show you one other quick little update with Excel, with MATLAB. As I told you, when we think of log, we should be able to take the log of 100, log base 10 of 100, and it should be 2, right? If I do log of 100, I'm like, wait, that's not 2. So as I was messing around with this code, I was like, what? So if we do log 10 of 100, there we go, there's 2. So the natural log of 100 apparently is 4.6 or whatever that was. So some time ago, I wrote up a bit of code, and the things that I've added were this piece, and I changed the log base 10. So if we go back to this solver thing we talked about some time ago, this is the previous example, not our current one, but that previous example we did with Excel Solver, slightly different situation. we had a Ka, we have the Kw for water, total acid concentration. We said we're going to install this little symbolic math thing and try it. We did that. We define a symbol H and then set up an equation to say the H concentration is equal to the solver when we take this left-hand side minus the right-hand side, multiply it by 1,000,000 just to make it more accurate, set that equal to 0. So this is our left-hand side minus right-hand side equals 0. So that's what this piece is doing. Then the other thing I changed, the only other thing was I said, let's constrain that from an H plus concentration from 0 to 1 moles per liter. That puts us in the pH range of 0 to 14. Now, when I do that and I take the proper natural log, we actually get the solution we were supposed to. We get, at that time, our pH was 5.56. And we could go back and look at that one. The other thing I did was I changed it to give me only real numbers, which previously it was giving us like 5 different answers. And I realized some of them were imaginary numbers. It was like pi times I as a solution. And so seems like the log change fixed it, or maybe this change here fixed it. In any case, as I was messing with stuff, I just said, assume we're in the real territory, and let's take the log base 10 instead of the natural log. So that cleared it up, and the stuff we did previously in the semester was actually working, just I had something wrong, right? That's pretty typical for MATLAB, right? It's like you're banging your head against the wall, and then you realize you took base E, and I wanted base 10. Something silly. Okay, so you're good for this homework for Thursday, and you'll have your other homework due Tuesday next week, and that'll be our exam review. We'll also have a lecture this Thursday to kind of finalize our titration stuff. Okay, so we'll see you on Thursday.